Okay, so today is lesson 4. I'm going to try to go a little bit fast because I don't want to take like 20 minutes. Here we go. A proportion is an equation that shows that two ratios are equal. So how do we solve a proportion? We use the cross product property. And what the cross product property is this. The cross products of a proportion are equal. So in order to verify that they are proportional, the cross products have to be equal. For example, given the numbers 3 over 6 equals 1 over 2, you know that 3 times 2 equals 1 times 6. And of course, we can talk about it also in words. In other words, A times B is equal to B times C. It's just in algebraically. So let's go ahead and get started real quick then. Let's go ahead and let's answer the question here. It says, use the cross product to tell whether the ratios form a proportion. So these are ratios. Ratios, we talk about ratios or fractions. So we're going to check if 9 over 51 is equal to 6 over 34. We're going to set it equal to each other. And then we do the cross product. So we're going to go ahead and do this cross product. We're going to multiply 9 times 34. And that's going to be 306. The way I do it is like this, guys. This is the way I do it. I go 9 times. So this is like the answer. I put it right here. Don't forget to put your equal signs. And what is 6 times 51? Well, if you work it out, 6 times 51 is also 306. So therefore, this is proportional. Because once you do the cross product and they're equal to each other, it is proportional. Let's go ahead and look at the next example. Next example would be this. Once again, set up the proportion. 12 over 20 is equal to 32 over 50. Let's go ahead and do the cross product. We're going to multiply 12 times 50. Well, 12 times 50 is 600. Now, we're going to put our equal sign. And then we're going to multiply 32 times 20. And 32 times 20, guys, according to my calculations, is 640. Are these equal? No. I'm going to put out this sign. That means it's not equal. Therefore, they don't form a proportion. Okay. Beautiful. So let's go ahead and move on to the next problems. On problems number 2, they're asking us to use the cross product to solve the proportion. Okay. In this case, guys, we have two ratios, but there's a problem. We're actually missing one of the, in this case, the denominator. So in order to solve for it, we're going to do the cross product and solve for the variable. How do you do that? We're going to multiply. I'm going to go ahead and use it since I'm already working here. That's already proportion. I'm going to multiply 4 times 30. And 4 times 30 is 120. Equals 24 times A. And that would be 24A. Now, what did I tell you guys? Whenever they're together, that means they're multiplying. In order to get rid of them, we have to do the opposite, which is divide. So we're going to divide by 24. One-step equation, right? This becomes a 1. A is equal to 120 divided by 24 is 5. Okay, look at the next example. We did one on the bell ringer the other day. And this one, you're like, wait a minute, how do we do this one? Well, the ones we did, they were flipped. The binomial, which is this, they were on top and the constants were in the bottom, but you solve it the same way. Remember I told you 2 times this, 2 times this, 8 times this is like the distributive property. That's exactly what we're doing. So how do we do this? We're going to multiply 2 times x minus 8, 2 times x minus 8, and we're going to multiply equals 8 times x plus 1. We're going to go ahead and multiply that. 8 times x plus 1. How do we do this? We do the distributive property. What do? 8 times x is 8x. 8 times 1 is 8 equals what? Same thing. What is, remember, whenever we have parentheses, we want to get rid of it by doing the distributive property for the most part. So 2 times x is 2x. And 2 times what? Negative 8. So that would be negative 16. Are we done? No. Now we have an equations with variables on both sides. So we're going to move the variables to one side and the constants to the other. So we're going to go minus 2x minus 2x. Cancel. What is 8x minus 2x? 6x. And then I'm just going to rewrite what I have. Is this I just bring the 16? No, it would be a minus 16. Remember, I respect the sign on the left. This is a two-step equation, guys, so we want to get rid of the number farthest away. Remember, we pretend they're like in rooms. How do we get rid of it? The number farthest away from x is 8, so I'm adding an 8, so I'm going to subtract, and I'm going to subtract. So the final, this becomes a 0, so we have 6x is equal to IO 16 and IO 8. Well, that would be IO 24. And the last step, guys, is divide. I'm running a little bit of space, so I'm just going to move it here. 6x is equal to negative 24. Divide by 6, divide by 6, it becomes a 1. X is equal to negative 4. And the last one, I'm going to go ahead and let you guys work it out. And then give you extra credit for working that one out. You should get a whole number. I already have the answer. You can, once I look at your notes, I'll give you credit for that. So I want to make sure you guys practice one. Next one. So now we're doing a word problem. In this word problem, it says proportion word problems. They're saying, hey, you swim 4 laps in 2.4 minutes. Okay? And you complete 16 laps in 12 minutes. Is the number of laps proportional to your time? Well, in order to determine if it's proportional, just like the way we did up here, when we checked if they were proportional, we have to create a ratio. Well, I'm going to go ahead and do this. I'm going to say that, okay, so I did 4 laps in 2.4 minutes. Is that equal to swimming 16 laps in 12 minutes? Well, the only way we can verify is by cross multiplying. 4 times 12 and 16 times 2.4. Way I already did. 4 times 12 is 48. Is that equal to 16 times 2.4? Unfortunately not. So guess what? This is not proportional. Okay, so go ahead and try number 2. You're going to have to use proportions. Just remember, the key is here that we put corresponding sides. If you notice, I put laps with laps, minutes with minutes. Okay, so bring me number 2. Work it out. In this case, this example, you're probably going to set up the proportion and solve for one of the missing ingredients. Okay, so moving on. We're going to go ahead and move to the back part. And here it is. We're going to be working with figures that are similar. Well, figures that are similar, okay, have the same shape, but not necessarily the same size. To prove figures similar, their corresponding angles must be congruent. In other words, guys, they're equal. And their corresponding sides must be proportional. Okay, so let's look at the first, let's go ahead and read the instructions. Given that 2 triangles are similar, okay. So what are the telling that are similar? Oh, same shape, different size. That means the angles have to be congruent and the sides are proportional. If they're telling them similar, this is what we're following. So then it says, label all the corresponding parts, then set a proportion. Set up a proportion. All right. So let's go ahead and do that. Well, I'm going to set up a proportion. I'm going to go and set up, I'm going to go and get A over B, which is 10. And A over C, which is 7. And who does that correspond with? Corresponds with DE, which is 20. And DF, which is 14. In addition, I can use the side BC, which is 6, correspond with the side BC over 7. My bad. Equals, this is a 7, guys. Equals EF, which is 12, over 14. Now, I'm sure this is correct. We can cross multiply and check that this is true. Now, these are the corresponding sides. Now, what about the corresponding angles? Well, actually, that's a little bit easier. The corresponding angles would be, for example, A over B is congruent to DE. Actually, I made a mistake on this one, guys. My bad. It's really easy. Angle A is congruent to angle A is congruent to angle D. This symbol, guys, means congruent, okay? It's like an equal with a little squiggly line on top. So what about B? Angle B corresponds with angle E, congruent. And last, angle C is congruent to angle F. Okay, I'm working on these videos, guys, so I'm going to try to do better next time, so just bear with me. Alright, so using this information, so what is this telling us? In order for it to be similar, let me just show you something real quick. You see this little two lines? That's why it's telling you that this one corresponds with that one, because we have one line that corresponds with that one. Those are the corresponding angles. Okay, it doesn't mean that it's like the degree or anything. It's just telling us that they're corresponding, which means they're equal. Alright, so let's go ahead and do this example, because I'm already going to be almost 12 minutes. I want to make sure I hurry up. You can fast forward or pause me, whatever you guys need to do. Find the length of the line segment AB, A prime, B prime after the dilation. So they want us to find this side. Well, let's call it X. Well, remember, we get a proportion from this, we get a ratio from this shape, from this triangle, where I'm going to say 4 over 6 has to equal what? Who corresponds with 4? Well, that would be 10 over X. So the 4 corresponds to the 10, and the 6 corresponds to the X. How do you solve this? Excuse me, cross multiply, divide. Okay, so we cross multiply and divide. Now, I'm going to go ahead and leave it like this, because I want to see if you guys can figure that one out. Bring it to me, and I'll give you, I'm going to give you points for when the notes are completed. So I already set it up for you, because this one is actually a little bit more challenging. So I'm going to stop there for that one, just cross multiply and divide. Now this one, guys, they're the same thing. They're asking us, what is the height of the pole? Well, that's beautiful, but there's a problem. Well, not necessarily a problem, but look, this is 15.5 feet, this is 5 feet 2 inches. So in order to use it, I have to have it all in the same, with the same type of units. So what I'm going to do, guys, I'm going to convert the 15.5 feet, I'm going to convert it first into inches. So 15.5 feet, guys, is, let me double check, but I'm pretty sure I got 182 inches. That's what it is. So how do I get it? Well, there's 15 feet, 15 times 12, and then half a feet is 6 inches. So this is going to be 182 inches. Okay, so 100, this is in feet, this is in inches. 5 feet 2 inches is the same thing as 62 inches, and then 7 feet 9 inches is the same thing as 93 inches. Now they want us to find the height of the pole, which is, we're going to call it X or H, whatever you want to do, and set up the proportion. The proportion is X over 182 is equal to who? Who does X correspond with? 62. Very good. Over 93. Cross multiply and divide. If I multiply 182 times 62 and 93 times X, you should get 93X is equal to 1,284. We divide by 93. We divide by 93. X is equal to 121.3333. That's what you're going to get in your calculator, which basically 100 and, which basically is 1/3. 1/3 of a foot. Well, if you 1/3 means you get a foot divided by 12, but divided by 3. 12 divided by 3 is 4. So therefore, it's 100. X is 121 feet with 4 inches. And go ahead. I'm just gonna go ahead and work out one of these examples, and I want you guys to do the rest. This example, guys, is only asking us to determine the similar, so you have to set up a proportion. I'm going to go ahead and do this one, and then lastly down here is this one, guys. What I would do is the same thing, just break them into two pictures, and then solve for the missing side. In this case, they're looking for the height of the tree. Now, look at they're saying here, hey, determine if each polygon are similar. If so, write the similarity statement and the similarity ratio. Well, how do we know they're proportional? Well, they have to be same shape, different size. Okay, that's number one. Number two, corresponding angles are congruent. Wait a minute, this is 20. I don't know if that's 20, but for sure, remember, this is 90. Okay, so this is 90, this is 90. Okay, beautiful. How do I know this is going to be what? Well, remember, this is a triangle. They have to add up 180. So we have 190. So then 90, what is this one? This is going to be what? Well, they have to equal 180. So this is 80. And this is 20. That's 100. Therefore, this has to be 80. Well, same thing here. If this is 90 and this is 80, we have to add up to 180. We're still missing 20. And guess what? They are congruent. So all we need to do now is create a proportion and solve to prove if they're similar. So it's 8 over 10 is equal to 25 over 20. No. Who does 8 correspond with? 8 corresponds to 20. So this is 20 over 25. Cross multiply to verify. 20 times 28 times 25 is 200. And 20 times 10 is 200. Therefore, yes, it is proportional. And that's it, guys. Hopefully it's not too long.